TypeScript can help you improve the developer experience of React components in a significant way. Here's just one way that can happen. Let's say we have an array of options like so, which have a specific type, but it's not clearly defined as an interface or a TypeScript type, and we pass those options as a property to our child component, and then our child component is smart enough to infer the type and show us what options we have available, what type of keys exist in each item of our array, so that if we remove one of the keys, we start getting type errors because our child component figures out that our entities and options no longer contain the key that we are using in our callbacks. But that's not all. We can even extend our type safety to conditionally require the existence of some parameters or properties based on the type of others. So in this case, I deleted getLabel from our child props, and because I'm not defining a label in our options, TypeScript will ask me to provide a getLabel method for my child. If I had a label here in the options array, now TypeScript no longer complains. So I'm able to encode some of my business logic and constraints directly in the type system instead of relying on runtime errors or runtime checks. This is surprisingly easy to implement actually. It only requires three main concepts from TypeScript. The first one is generics, the second one is type inference, and the third one is conditional type. So let's go ahead and check that out. Let's start off with just a simple React component and not worry about what we're going to build inside it, because this is going to be about types, not about React component implementations. Our component will have a type for our props, and this type will contain probably the options. And let's just start off with an array of objects that just contain IDs. A getLabel, which will work with objects of the same type as options, and an onChange, which should probably also tell us if we have unselected items, provided that this would be a drop-down or a combo box or something like that. Now, if we take a look at our instantiation of the child, we see that we need to provide the getLabel method, but we notice that now our entities don't understand that they have a label. Even though we clearly send a label here in the options array, our child is not generic, it doesn't understand different types being passed to it, so it doesn't see label as a property of the entity in getLabel. In order to enhance the type capabilities of our component, we need to add our first generic, and we can say it extends the object that contains IDs, basically enforcing TypeScript to only accept arrays that contain objects with the key ID. And now we can get rid of all the static types that we defined here and replace them with our generic. We also need to provide a generic type for our child component, like so. And now our component almost behaves like we want to. Our options are inferred. We know exactly the type of keys that we have available. We have access to the label, to the name. If we rename something in our array, we no longer see the label on the entity. But we still have the problem when our label exists as a key in the options array. When we remove the getOptions label, our child component still complains because it doesn't understand that our getLabel should become optional. Now, in order to make our getLabel optional only if our options contain the label key, we need to transform our child props into a conditional type. It's actually quite easy to do that. We just add an additional extension here to our initial type declaration that we have. And inside it, we check if our option, our inferred option type, also contains a label. Now, in this ternary operator, we check if our inferred type for our options contains a label as a key. If it does, our getLabel can be optional, otherwise it can be required. And now if we take a look at our instantiation of our component, we see that we no longer are required to provide a getLabel because we have a label key, and if we rename that to something else, we now need to provide getLabel in order to make that error go away. This combination of generics, inference, and conditional types can be used in other places. For example, we can have a layout that will never accept a sidebar slot without a content slot. Let's say that our design guidelines forbid us from using a specific sidebar if there is no content. We can encode this constraint directly into our type system with a similar approach. Here I define all the slots of the layout as optional, but I use a generic for the sidebar slot. Even though it extends React Node, I will use this as an infer type to be able to do some conditional branching for the type later on. So my layout props can actually contain everything that was in the base prop, so all the slots as optional, plus I can check if the sidebar is null or undefined and I can do nothing, or if it is an actual React component or element or something like that, I can say, hey, I actually need the content to be required and I'm not even sure what the type is. So just take the type of the content from the base layout prop that I defined above. So there we have it. With just 3 simple TypeScript tricks, we can drastically improve the developer experience for our React components. If you're doing something similar to this, let me know in the comment section below. And if you like this video, please consider subscribing and liking it. It's going to help me a lot. Having said that, have a good day and I hope I'll see you in the next one.